Hi everyone, Vega here, and in today's video I thought we'd have a look at the Taurus constellation, seeing as it is, at the time of release of this video, the time of the year of the Taurus star sign in the signs of the zodiac. And we can see here that straight away that Taurus is sandwiched in between Orion, which is perhaps the most famous constellation of all, and Aries, of course, the ram, which sort of makes sense, doesn't it? Because the sign of the zodiac immediately before Taurus is Aries, and then of course Pisces before that, and indeed Aquarius before that. And when we talk about Taurus, I think what immediately springs to mind is there are perhaps 3 stars that are quite famous in the Taurus constellation, but one of those stars is by far and away the most famous, and that of course is Alpha Tauri, or Aldebaran as it's most commonly known. A big red stroke orange giant star, K5-3. And it's quite interesting, isn't it, that there's actually a plus sign there next to the Aldebaran spectral type. And the plus, what it really means is that it's on the borderline between 2 spectral types or luminosity classes. For example, an A0 plus would be slightly hotter or closer in characteristics to the next subtype. Not quite hot enough, perhaps. So what I'm saying is that Aldebaran is actually pushing towards the bright giant class, so it's almost a K5-2 star, but it remains in the giant branch rather than the bright giant branch, which is spectral class 2, of course, in the classification, as we can see here. So Aldebaran is somewhere in between bright giant and normal giant, but just in the normal giant category, which is what the plus means. Aldebaran, of course, 65 light years away, and indeed one of the brightest stars in our skies, coming in at 14th with a visual magnitude of plus 0.86, and it does vary a little bit. The beta star of Taurus is an interesting star, Beta Tauri, also known with an official name of Elnath, and Elnath is the 27th brightest star in the night sky, and is, as you can see there, is a B7 giant star, so it's on the cooler side of the B class at 130 light years away. But it's actually really quite bright, isn't it, Elnath, at plus 1.65, and certainly reaches 27th brightest star in the night sky, sandwiched there, as you can see, between Bellatrix and Mir Placidus, with a luminosity 700 times the sun. And Elnath has evolved to become a giant star larger and cooler than when it was actually on the main sequence, so it's actually cooled somewhat, even though it's still very hot, isn't it? It's a B-type star at 13,600 Kelvin there, as we can see. Still very hot, but quite interesting that it's cooled down. You don't really often think that B-type stars, when they expand, even though they remain in the B class, do actually cool down. So at one point in its history, Elnath would have been higher, perhaps a B0 or a B1, possibly even in the O class, until it expanded and cooled down somewhat. Of course, Taurus depicts a bull figure, doesn't it? As you can see in this picture. And Aldebaran, as you can see, is right in the middle of the head, in fact, slap bang in the middle of the Taurus constellation. And again, it's right next to Orion, isn't there? So you can see Bellatrix and Betelgeuse, some of the famous Orion stars. But perhaps the most interesting other thing other than Aldebaran in the Taurus constellation is, of course, the Pleiades cluster, which sometimes known as the Sisters, the brightest star of which is known as Alcyon, which is Eta Tauri, with an apparent magnitude of 2.86. And as you can see there, these are all the stars in the Pleiades cluster, and they're all very close to each other. You can see they're all roughly 400 light years away, and they're all B-type stars, some still on the main sequence there, as you can see with what looks like a V is actually a 5 designation, and some slowly moving off like Taigeta or Merope, which have moved up to the 4 designation, and some are even expanding further like Maya, and indeed Alcyon itself, which is now a bright B-class giant star. So lots of interesting stars there. Don't forget to check out the video on Aldebaran and the Pleiades if you haven't already. As it says there, the brightest stars are cluster names as the 7 Sisters. I've often thought that the Pleiades looked a little bit like Ursa Major, a small version of it, as you can see. But also another one that's perhaps not as talked about as the Pleiades is the Hyades star cluster. As it says here, it's a bright, large, open cluster of stars located 153 light years away in the constellation of Taurus, and the nearest open star cluster to the Sun. And it says the brightest stars in the Hyades form a V shape along with the brighter Aldebaran. Of course, Aldebaran is unrelated to the Hyades cluster. And interestingly, in this graphic here, we can see what this represents. This picture here that we can see is the density of stars in our local 100 parsec area. These colours here are density of stars per cubic parsec, and we can see that obviously there in the Hyades there's a very dense amount of stars. Elnath is inside that area just while we're looking as well. Some quite interesting places, isn't there? Spica Nebula, which has obviously got quite a high density of stars. Achernar is in this one, the Tucana Horologium Association, and they're the Ursa Major moving group, which presumably contains some of the Ursa Major stars too, which is quite interesting, isn't it? We can see that there's quite a large sort of cloud, shall we say, of stars here, getting denser towards the Orion constellation, the Orionis group it's known as. We're not saying that they're very dense, but for example, in this Orionis group, there's 95 to the minus 6 stars per cubic parsec, which is around 0.00095 stars per cubic parsec, which doesn't seem very much, does it? But obviously it's quite a large density compared to where our own star is, which as you can see is pretty much in the middle of nowhere. So clearly what we can see here is that stars throughout our local area certainly aren't spread evenly, and the Taurus constellation has this grouping, the Hyades grouping, where there's quite a large density of stars really. It came to my attention on a comment from one of my videos where Michael Luca asked me to post a video about 119 Tauri. Now, I did have a look at the star itself, and it's perhaps not valid for a video on its own as it's a very unknown star, but being in Taurus, having a look, it is actually quite an interesting star, and thanks for mentioning that, Michael, because it appears to be almost a Betelgeuse replica. We can see it's got a designation very similar to Betelgeuse of an M2 supergiant, and a mass of similar amounts with 14.37 solar masses. Similar radius there, as we can see, both around 600 to perhaps at most 700 solar radii, and both around 66,000 solar luminosities. So very, very similar stars, 119 Tauri, and of course the much more famous Betelgeuse of Alpha Orionis. The difference being that 119 Tauri, of course, is much further away, 1800 light years as opposed to just 548 light years for Betelgeuse. So quite an interesting point there made by Michael, and also the age being very similar as well. Just the only difference really being the apparent magnitude, and that's down to the distance really rather than anything else. So 119 Tauri, almost a replica of Betelgeuse. Zeta Tauri, or Tianguan, is another bright star in the Taurus constellation, binary star of a large B-type giant star and what looks to be quite a similar star to the Sun, in fact, at 0.94 solar masses, so perhaps a G-type, a main sequence star with a stellar flash location of G4 at 440 light years away. The G-type star is not the star that really we're looking at the light, because it's just too dim from that distance. In fact, the Sun from that distance would be an apparent magnitude of over 10, so it would be invisible to the naked eye. So Zeta Tauri Tianguan, which presumably is the A star anyway, is an interesting system, but the one we can see is the A star, which, as I say, is this B-type giant star with an interesting designation of PE at the end, with the P meaning that it's a peculiar star with an unusual metal abundance. So there's certainly some strange abundance of metals going on, and the E being emission lines are present. Achernar, of course, is another peculiar star. So Zeta Tauri is quite an interesting star, really, isn't it? The two stars orbit with a period of nearly 133 days and at 1.17 astronomical units. That's quite curious, isn't it? That obviously Zeta Tauri A is a star that's extremely powerful and far more powerful than our Sun. But if it were a planet, it would actually be in the habitable zone of Zeta Tauri b, which I find quite ironic, really, and interestingly. The general catalogue of variable stars lists it as an eclipsing variable and a Gamma Cassiopeia variable, but it may not be either. Now, obviously an eclipsing binary is one where the two stars eclipse each other. A Gamma Cassiopeia variable shows irregular changes in brightness on a timescale of decades, which is quite curious, isn't it? Because it's obviously not being affected by the orbit being just 1.13 astronomical units apart. It's not going to be decades for them to make one orbit. And it says these type of variables are understood to be hot stars which have an equatorial decretion disk, which periodically disappears and then reforms. Now, a decretion disk, unlike an accretion disk, which involves material spiraling inward towards a central object, decretion disks are created by material being ejected outward from the star due to its rapid rotation and other forces. That's quite curious, isn't it? In terms of the disk is being pushed outwards rather than inwards, and sometimes known as shell stars. Of course, that's the Gamma Cassiopeia variable, but we don't know that Zeta Taurus is either. So in terms of other things in the Taurus constellation, the main thing that springs to most people's mind would be the Crab Nebula, as we can see in this beautiful depiction here. And the Crab Nebula is a supernova remnant and pulsar wind nebula. The Crab Nebula was first identified in 1731 by John Bevis, and indeed the Crab pulsar in the centre meant that the Crab Nebula became a major centre of interest in the 1960s, when Franco Pacini predicted the existence of the Crab pulsar for the first time, which explained the brightness in the cloud. So the Crab pulsar is thought to be a remnant of a supernova actually observed in 1054, and then obviously later on identified. So certainly one of the few supernovas that humanity has documented, and we can actually see progress through its lifetime, or I should really say its death, turning into a pulsar, which is quite an interesting place, isn't it, the Crab pulsar? Let's do one more star in Taurus. 27 Tauri is a triple star system in the constellation of Taurus and a member of the Pleiades Atlas, which is a good name, isn't it, for a star? And as you can see there, Atlas is this one here in the Pleiades cluster. So there you go, a brief look through the Taurus constellation and its famous stars, primarily Aldebaran, but obviously some other interesting places like the Hyades or Pleiades, and indeed 119 Tauri. So take good care of yourselves, look after your friends and family as well, and I'll see you on the next one.